set 1.2 practice set 1.2 question number first given below are some triangles and lengths of line segments identify in which figures ray PM is the bisector of angle QPR. The first figure is PQR 3.5 1.5 3 7 in triangle PQR given PQ is equal to 7, QM is equal to 3.5, MR is equal to 1.5, PR is equal to 3. Now PQ divided by PR is equal to 7 divided by 3. Give this equation number 1. QM divided by MR is equal to 3.5 divided by 1.5. 5 3 15, 5 7 35, that means 7 by 3. Give this equation number 2. From equation 1 and 2, PQ divided by PR is equal to PQ divided by PR is equal to QM divided by MR. Therefore, by angle bisector theorem, therefore by converse of angle bisector theorem, we have ray PM is the bisector of angle QPR. This is the first example. Now second, number 2. See the figure. Again, triangle PQR is given to you. Ray PM, PR 7, PM PQ 10, MQ 8 and RM 6. See here. In triangle PQR given PQ is equal to 10, PR is equal to 7, MQ is equal to 8 and RM is equal to 6. Therefore, PQ divided by PR is equal to 10 divided by 7. Give this equation number 1. Now QM divided by MR is equal to 8 divided by 6. That is equal to 4 by 3. Give this equation number 2. From equation 1 and 2 again, PQ divided by PR is not equal to QM divided by MR. Therefore, ray PM is not bisector of angle QPR. This is the second example. Now third example. See here. The third figure is again triangle PQR. Here PR 10, PQ 9, QM 3.6 and MR 4. In triangle PQR given PQ is equal to 9, PR is equal to 10, QM is equal to 3.6, MR is equal to 4. Therefore, PQ divided by PR is equal to 9 divided by 10. Give this equation number 1. QM divided by MR is equal to 3.6 divided by 4. We write it as 36 divided by 40. 4 के 4 शून्य 4 नम 36. That means 9 by 10. Give this equation number 2. Again from equation 1 and 2. From equation 1 and 2 we have PQ divided by PR is equal to QM divided by MR. Therefore, by converse of angle bisector theorem, angle bisector theorem. Angle bisector theorem. A ray PM is the bisector of angle QPR. This is the third example. Question number 2. In triangle PQR, PM is equal to 15, comma, PQ is equal to 25, comma, PR is equal to 20, NR is equal to 8. State whether line NM is parallel to side RQ, give reason, and figure is given to you. P, Q, R, N and M. तर सोल्युशन पहा, काय काय दिलं ते आपण फिगर मध्ये लिहू. PM इज 15, PQ इज 25 and PR 20. PR is given 20, NR 8. Given PM is equal to 15, comma, PQ is equal to 25, PR is equal to 20 and NR is equal to 8. Now in figure, P dash M dash Q, that means M lies in between P and Q. Therefore, MQ is equal to PQ minus PM. That means PQ is 25 minus 15 is equal to 10. Now, P dash N dash R, PN is equal to PR minus NR. That means 20 minus 8. Therefore 12. We write in this figure MQ is 10 and PN is 12. Now in triangle PRQ, PM PN divided by NR is equal to 12 divided by 8. 4 दूनी 8, 4 त्रिकोण 12. That means 3/2. Give this equation number 1. Now PM divided by MQ is equal to 15 divided by 10. 5 दूनी 10, 5 त्रिक 15. That means 3/2. Give this equation number 2. From equation 1 and 2, from equation 1 and 2 Pn divided by Nr is equal to Pm divided by Mq. Therefore, by converse of BPT theorem, basic proportionality theorem, line NM parallel to side RQ. Now question number 3. In triangle MNP, NQ is a bisector. Is a bisector of angle N. If Mn is equal to 5, Pn is equal to 7, Mq is equal to 2.5, then find QP, and figure is given to you. See in this figure. P, M, Q, here is N, P. MQ is given 2.5, Mn 5, and Pn 7. In triangle MNP, ray NQ is bisector of angle MNP given. Therefore, by property of angle bisector of property of angle bisector of triangle, Mn divided by Np is equal to Mq divided by Qp. Therefore, 5 divided by 7 is equal to 2.5 divided by PQ or QP. Now 5 into PQ is equal to 7 into 2.5. PQ is equal to 7 into 2.5 divided by 5. We reduce it. We have PQ is equal to 3.5. This is the answer. Now example number 4. Fourth example. measures of some angles in the figure are given. Prove that AP divided by PB is equal to AQ divided by QC, and figure is given to you. See the figure. A, P, Q, B and C. 60 degree. We have to solve now. Angle APQ is equal to angle ABC is equal to 60 degree given. Corresponding angle test. Therefore, in triangle ABC, a PQ parallel to BC. Therefore, by basic proportionality theorem, BPT theorem, we have AP divided by PB is equal to AQ divided by QC. Hence, we proved it. Now, example number 5. In trapezium, what is the example? In trapezium, ABCD, side AB parallel to side PQ parallel to side DC. AP is equal to 15, comma, PD is equal to 12, comma, QC is equal to 14, and find BQ. We have to find BQ, and figure is given to you. A, B, C, D is the trapezium. Side AB parallel to side PQ. Now काय दिलं ते आपण लिहू. AP 15, PD 12, QC 14. We have to find BQ. Side AB parallel to, we have given that side AB parallel to side PQ, parallel to side DC. Therefore, by property of three parallel lines and their transversals we have AP divided by PD is equal to BQ divided by QC. You know that. Now AP is 15, PD is 12, BQ is we have to find, and QC is 14 given. Now 12 into BQ is equal to 15 into 14. Therefore BQ is equal to 15 into 14 divided by 12. 2 सख्खा 12, 2 सत्ती 14, 3 दूनी 6 and 5 15. BQ is equal to 35 divided by 2. BQ is equal to 17.5.